Hey Valley Middle, welcome to a math video. Tonight we're going to be looking at the relationship between lines, equations, and tables. So let's go ahead and start with our just for fun question. Who is Stanley, Kirk, Burrell? I'll give you the answer to that at the end of the lesson. Officially tonight we have two, they sound complicated, but they're really not that complicated. Here are the two targets. I can graph data to show the relationship between tables, graphs, and equations. I can complete function tables and identify coordinate pairs in that table. Really what we're looking at is, can you look at a set of data on a table and can you graph it? That's number one. And number two, do you understand how an equation, a table, and a graph work together? Do you understand the relationship between them? I think we can do that tonight. Let's take a look at a real life problem just to kind of start with. First of all, many of you know that I plow snow, and so this little function table I've made here can help me figure out how much or how many hours of work I'll have to do for a given snowfall. So if I have 1 inch of snow, I generally have to work 1.5 hours. And if I have 2 inches of snow, it's about 2.5 hours. 3 inches of snow, 3.5 hours. And so one begins to ask, well, what if you have 0 inches of snow? What if it doesn't snow? Well, I still got about a half an hour work because I still have to get the truck ready, put the plow on, and I'm up checking the weather and things like that. So, yeah, 0 hours of snow is still a half an hour work for me every time it's in the forecast. So, I've got this little table here. What's really going on? Well, really, the rule is whatever the x is, we're going to add a half to it. So, it's x plus a half or x plus 0.5. Now, we can take these x values and y values here and just put them into ordered pairs, like I have here. I just took them, set them next to each other, and put a comma next to it. Now you recognize that as an ordered pair. And we can graph those. Here's this first one here. And I'm going to close these just so that you get used to looking at them right from an XY chart. I'm going to graph 1, 1.5. So here, grab my point. Always start at the origin. I'm going to go over 1 and up 1.5. Grab another one. I'm going to start at the origin. I'm going to go over 2 and up 2.5. And I'm going to grab it, oops, and do the next one. Let's go over 3 and then we'll go up 3.5. And there's nothing magical about that. I just went the first value, I'm going to go left or right on. I'm going to move forward or back. And the next value, I'm going to go up or down. This is your x and your y coordinate. So put a line right on there, and I could use that line then to predict other things. Like I could look and say, well, if I get, 5 inches of snow, I'm going to have 5.5 hours of work to do. All right. This is an example of how these work together. The third piece is the equation. Well, we already know what the rule is. The rule is it's whatever x is plus 5. All the equations, you just say that y is equal to that. Y is equal to whatever x is plus 0.5. So you've got the table, you've got an equation, and you've got this graph. And all three of these work together in unison, and they really have this relationship. I mean, if I had just this graph, I could make this table and I could write this equation. If I had this equation, if I just had the equation, I could make the graph and I could make the table. Yeah. All right. In this situation, we start off with the table. We did this, and then we wrote that. But you only need one of the three to produce the others. All right. Let's take a look at some must-know words. First of all, the function table, in case you forgot, it's just this XY table we've got here. An ordered pair or coordinate pair, that's just these x and y values that you can actually graph. All right, here's the third piece of the puzzle, or the second piece of the puzzle. Here's the graph, and here's the third piece of the puzzle. Here's the equation that goes with that. All right, let's take a look at three specific situations. We'll look at a situation where you start with a graph like we did, and you have to produce the other two. Then we'll look at where you start with an equation, and you have to produce the other two. And the third one is maybe the hardest. You'll start with a graph, and you have to produce a table and an equation. All right, here's the first situation. We're starting with just an XY table here, and let's pop the values in. And we have to graph the ordered pairs and write an equation. Well, let's start off with the graphing. That's pretty simple. We've got the XY values right here, 0, 1, 1, 2, and 2, 3. So let's go ahead and put those guys on there. 0, and then we're supposed to go up 1. Again, remember, you go over first. In this case, we didn't have to go over at all. Now we've got 1, 2, so we'll go over 1. Oops, go over 1, up 2. And the last one is over 2, up 3. You would not believe how hard it is to graph on top of this with your mouse. All right, stick the line on there, and that's pretty close. We've graphed that line. All right, now we have to write the equation. Well, what's the rule? Well, the rule is just whatever x is, and you add 1 to it. So if x here was 100, this would be 101. So that's what the y is equal to. Y is equal to whatever x is plus 1. And we've just done that. So now I'm going to give you a situation where I give you a table, and I'm going to ask you to graph it. And nothing as fancy as this. Just make an x and a y axis, and just kind of put the points approximately where they are. Just kind of air graph it, I call that. And then write an equation. Figure out what the rule is and see if you can't write it as a y equals x statement. All right? Let's take a look at our first pause problem. Okay, see what you can do with this. All right, well, I cheated a little bit. I think I have my graph all put together here, so I'll just go drop this in. And I got 0, 3, so I'll just put that first point in, over 0, up 3, and the other points should line up. I'll just double check them. 1, 4, over 1, up 4, that looks good. And I skipped 2, just to show you that these x values don't need to be sequential. It doesn't matter. Put in 3, and there's my 6. Okay, so I've got that down, and what's happening? It looks like plus 3, right? So that just means the equation is y is equal to x plus 3. I'm betting you did that, and you realize that, yeah, this isn't as complicated as I thought. Okay, let's take a look at another situation. Now we have a situation where we're starting with the equation, and we have to make a table, and we have to graph it. All right, so what are we going to do here? Well, making a table is pretty simple. Just grab it here. We just make an XY table, and you get to pick the values. I like using 0, 1, 2. They're small numbers, which means the smaller the numbers, the easier it is to graph. So if I put 0 in here, if I substitute 0 for x, this is really what we're looking at. Y equals, it's going to be 2, and then you substitute it in a set of parentheses like this, 0 minus 1. Now, I'm not going to type them all out, but this is what you're really doing. So y is equal to 2 times 0, which is 0, minus 1. So this one's going to be minus 1. And then I could substitute this one in. Y is equal to 2 times 1, which is 2, minus 1. Well, that's just 1. And if I substitute the 2 in, 2 times 2 is 4, minus 1 is 3. So there, that was pretty, I mean, that's not going to hurt anybody making that table. So now we just graph it. We just put these numbers on, and I took some shortcuts to make it easier for us. 0, negative 1, so I'm over here at 0, and I go to negative 1 right here, and everything else should line up. Let me just check. Do I have 1, 1, over 1, up 1? I sure do. And do I have 2, 3, over 2, up 3? There you go. You started with an equation, and you were able to graph it and create the table. All right, now it's your turn to try that same thing. Here's your next pause problem. Go ahead and give it a shot. All right, let's do the table again first. I think that's probably easier. Oops, I got to find my table. There it is. Just open this up for you. I don't know if we need to look at the ordered pairs, but you can see I substitute everything in this time so you can get that visual cue. And now I just have to graph it. So my order pair is 0, 2. Get this guy in there. Go over 0. And go up 2. And then I'll just check to make sure that I got the right one here graphed. I got 2, 8, over 2 up to 8. That's good. And I got over 4 up 14. Yeah, that one looks pretty close. I had to aerograph that one, so that's pretty darn good. All right, there we go. Nice work. All right, now we just have to look at the third situation. The third situation is where you're given a line, and you then have to make a table and write the equation. This one may be a little bit harder, especially working here online, but let's just see if we can't figure this out. So this first point then looks like we go over 2 and we go up 1. So the y value here is going to be 1. And the next point looks like we go over 4 and up 2. So I click in my 2 point, and this other point looks like you go over to 6 and up 3. It looks like it's a half of what it is. So my guess is that if I had 100 here, it would be 50. Now let's just see. What if it was 1? Well, if it was 1, it would be half of 1, which is a half. Let's see. Over 1, up, looks like a half. All right. So my equation is, I'm just going to move this. My equation is y is equal to x divided by 2. That's one way of thinking about it. Or y is equal to 1/2 x. These are the exact same things. A half of x or x divided by 2. They're the same things. All right, let's have you try one here. Get you set for your next pause problem. Same thing, quick. Read the points on the graph, make the table, write the equation. Okay, if you're struggling to read the points, I can give you the ordered pairs. It'll help you make your XY table. All right, well, here's your XY table. 0, 0. 1, 2, 2, 4. Really what's going on here is it's just times 2, right? So my equation is y equals 2x. Pretty straightforward. All right. Now the next portion of it is about the y-intercept. And some people think that this is too hard for 6th graders. I don't. I actually think it makes a lot of sense. The y-intercept is where the line crosses the y-axis. So this is the y-axis. So wherever it crosses the line, whichever one of these points, it could be 5, 4, 3, 2, 1, 0, negative 1, negative 2, that's called the y-intercept. So this one here, this just crosses right here, right now at 0, 0. So whatever y is equal to, x is equal to. So look at over 1, up 1, 1, 1, sorry, I moved it, 2, 2, 3, 3, 4, 4. Okay, this one here, the y-intercept is at 1. You see where it is? See how it's just plus 1? We're just at 1 there. Here's the plus 1, and that shows where it crosses the y-axis. This one here is y is equal to x plus 2. Notice, it crosses at 2. Okay? Now, even if this line were a different angle, let me just put a different angled line in here. Let's make it magenta. Actually, I don't know what magenta is, but we'll just put magenta in. I don't know. Even if it was this line right here, we don't know what x is. It's still going to be plus 1 because that's where it goes through the y-axis. This one is probably something like 2x plus 1. Let's take a look at some more examples. Look at this one here. This one is y equals x plus 3 because look where it crosses the y-axis. Here's the plus 3 and it goes through at 0, 3. That's because when you put 0 in for x, you're going to have 0, 3 as your first point. Look at this guy's negative 1. And look at, here's the negative 1. So you start looking at these equations, y equals negative 1, you go, hey, it's going to go through down here, negative 1. You already know 1 point. Look at this one. Here's negative 2. Y equals x minus 2. So this one we knew had to go through down here at negative 2. I think I got that right there. It's just a little low. Okay? All right, so let me just try this little activity with you. Here I've got 6 little graphs. See if you can figure out which one of these goes with each one. So look at this first one here. What does that one look like? Yeah, you're right. That first one is y is equal to x. Whatever x is equal, y is equal to 1, 1, 2, 2, 3, 3. How about this guy here? Okay. I don't see that one either. Oh, there it is right here. It's got to be minus 2, right? Because it goes through at minus 2. There you go. How about this one? Well, it goes through at plus 3, so it's got to be this one right here. Y equals x plus 3. How about this guy right here? Ooh, there's no plus or minus, right? So it's got to be either this one here or this one. It actually happens to be this one here, y equals 2x. Because look at, when x is 1, y is 2. When x is 2, y is going to be up here in 4. All right, how about this guy right here? Yeah, it's got to be minus 3, absolutely. That means this one's got to be y is equal to 1/2 x. Let's just see what happens. So we go over 2, that's x. We're up 1, yeah. Over 4, up 2. Y is equal to whatever x is divided by 2. All right, that's y-intercept. I think it's a powerful thing, and I think it can help you when you're looking at equations and graphs and determining which one goes with which. All right, for your ticket to the show, I would like you to just go through and look at these tables here and complete this table. You've got a function up here, and go ahead and identify the coordinate pairs very simply. The next one here, I want you to determine what this equation is right here, what's underneath here, and make a quick graph of it. All right? All right. So make sure you write that equation in the y equals x form. Okay? Yep. All right. Who is Stanley Kirk Burrell? It's MC Hammer. He wore these crazy pants into this song, You Can't Touch Us. It was awesome. I was a child of the 80s. You guys are lucky I survived all the weird stuff that went on. But look at that. Look at these babies. Yeah, how would you walk in those? But he had a cool dance to him. You guys probably don't recognize him. Your parents probably do. But you probably have seen him referenced in Super Bowl commercials and other Cheeto commercials. He's kind of the spokesman for Frito-Lay or Cheetos or whoever makes those. All right. Thanks for listening. Bye.